Hello and welcome to this tutorial. In the previous series of tutorials, we've looked into how to set up a 1D steady flow model. We also looked into how to start a bridge covert, and we did a couple of simulations. We looked at ineffective flows, editing bank stations. We also looked at how to set up a levee to constrain the flow within the channel. In this particular tutorial, we are going to be looking at how to inspect the HECRAS model output. So we are going to do that together. So to do that, we need to open up the result table. So we go into the result table, see that the HECRAS output. So we are basically looking at two things here. We are going to be looking at the water surface elevation. We look at the peak flow, and we also look at water surface elevation. So for this particular road, the road is built to hold uh, 50 to 100 year peak flow. So we are going to be looking at 50-year peak flow. Even though the results is showing that this particular crossing can take the 50-year and the 100-year, even the 200-year, but we are also going to just focus on the 100 and the 50-year, and possibly the 100-year, but more focus on the 50-year to see the water source elevation and compare that to what we have. So we're going to go back to the model output. So we have the table. To get the table, the water surface elevation, we need to look at the first cross section to the culvert. So this is the first cross section. So we need to get this information. The peak flow is 1410. The water surface elevation is 1155.67. So we can go back to the model table and fill up the table. So the peak flow is 1410. The water surface elevation is 11567. We also have that information. I'm going to bold these. We also need to bold these. We need to get the covert invert elevation. The covert invert elevation, we can get that from the model. So go to the model. We go to the covert. So edit covert. The covert. We have the upstream invert elevation. So we need to copy that out. And we can go back to our model and put that information. We need to make it bold. Then we need to calculate the headwater depth. The headwater depth is the difference between the water surface elevation and the covert invert elevation. So we can say the difference between the water surface elevation and the covert invert elevation will be 10.67. If we do the math correctly, that should be 10.67. And we need to know the covert depth, so we can go back to our coverts and get that information. So we need to go back to the coverts, and we know that the covert is 6 feet. So that information is important. So we can go to here and put 6 feet. We need to make all those values bold so we can easily refer. So now we have the parameters we need to calculate HW/D. So by the time we are able to go in here and divide the HW, the headwater, by the cover diameter depth, that value should give us roughly 1.7. And we can also check other data to see if we have, um, sometimes it's okay, this value can go even up to 2, can range up to 2. or more. But at that time, we need to begin to check to see if we set the ineffective stations properly or the deck is well defined. If the deck is well defined, then we should be able to bring that value down. But this is just a rough estimate to show how to calculate these parameters. Optimally, we want to see values around 1 to 1.5. But when the value is lower than 1, shows that probably the, uh, the bridge opening is too small. It cannot carry much water. And then we can also compare the water source elevation with the deck. If we have a free board, so at the top we have 116762, here 115. So that difference should be so we have about 11.9 feet of freeboard, and then we can have allowance to we can go back to check for other um, problems or what could be the problem. So basically, this is how we check for the parameters we look at for. Basically, looking at for the water surface elevation, and we compute for the headwater depth all over the depth, for the cover depth to get the values. And to learn more about the HWD and other parameters, you can look into the HECRAS hydraulic manual. So that is how we can expect these values. In the next couple of videos, we are going to look at how to modify the Manning's-N from land cover data, and that will be, and then we can look at a couple more other areas to keep iterating the model and how to edit cross sections, existing cross sections, and make it even better. And that's how we can end. Then we can end the tutorial. But go ahead and save, and we can meet in the next series to complete the other task. So I will go ahead right now, and I'm going to save my geometry and close, and I will see you in the next one.